This is for Casey and Jason watching this video. This is the second half of section 5.2, and actually it's less than half because we only have 3 examples left. This is the very, very, very back page of the stapled page. Before we start this, I'm going to explain to you what's going to happen over the next week. Your semester test in this class is on Monday. It's the second period on Monday. It starts at 9:45 on Monday. You get it over and done with on Monday. All done. But we do not start review until Wednesday. So today and tomorrow we'll be doing this stuff, which is fair game. It will show up on the test, on the semester test, but you won't have a regular test over until we finish the chapter in January. Make sense? We'll review over what we went over. Yep. We'll review over what we went over. We will finish the rest of the lessons in the chapter. We will stop, take a test in January, and then we'll move on to chapter 6 in January. Okay, but over this stuff, we have 3 sections. We'll some of that stuff will show up on the semester final. Semester final, we start reviewing for on Wednesday. So Wednesday, Thursday, Friday, that's 3 days of review. You get a review packet, just like always. Yep, you get to use it, all that good stuff. So we'll go over that when we get to it. But today, tomorrow, we're going through this stuff. Tomorrow, we'll probably turn homework in, and then we might do some more exponent stuff. But if we don't, I don't know. We'll see. We'll see.
Wait,
we'll see what I feel like.
Take a whole day.
What?
This page.
No, we're gonna.
Yep.
What are you talking about?
You said we're gonna do this today and tomorrow.
This is no. Tomorrow we're doing chapter 5 stuff.
Stop.
Yes. So anyway, starting with example 6. Here we go. The radioactive decay. We have 3 examples. 6, 7, 8. You need your calculator if you don't already have it out. And here it goes. The amount of 1 kilogram, underline 1 kilogram, so we have, or circle it, or box it, or something. 1 kilogram of plutonium. And this is the, chemical element notation of plutonium. That remains X years, after X years can be approximated by this function, okay? So, X years later, it's dividing off. This is a number that's less than 1, so this is an exponential decay, but it's not decaying very fast, right? After 1 year, 99.997% of it is still remaining, right? And then after 2 years, it's a little bit less and a little bit less and a little bit less. So it's taking a long time to decay. Estimate the amount of plutonium remaining after 10,000 years. What do? We plug in 10,000. We plug in 10,000, right? So 0.9, practice typing this in, to the 10,000 power equals, we're just plugging this in. What? How much plutonium is left?
Why did you just say
0.74? Is that right?
0.74.
What? 0.74. 0.74. What were we starting with?
Oh, I guess.
Yeah,
We started with
1.
what? You did not get that? Did you? You do an F zeros?
Yes.
0.99997. Oh, you're missing a 9. Okay, 0.74. So, okay, we started with how much? 1 kilogram, and we have 0.74 kgs left, right? I have 0.74 kilograms, so it's like 3/4 of, or it's decayed about 25%. 25% of it has decayed in 10,000 years. That's crazy. That's not a lot. All right, exponential growth and decay. Now we're going to be dealing with stuff that involves e's, and that happens in exponential growth and decay a lot, specifically in compound interest. Like people at the bank who calculate loans and things like that, or investment people, they're constantly using e's. Probably the calculator or the computer is doing it for them, but E is embedded into formulas that are in the calculator or in the computer, and that is what helps to calculate your compound interest and stuff, okay? So there is an irrational number denoted as E. You have a button on your calculator that is E, yeah? Yes. It is next to the LN button, so you might have to hit Shift LN.
I have an E.
Okay? No, that's not what, that's not what you want.
Not
You don't
that.
want an E. It's LN. It's on the LN button. It's like E to the X power.
Is right there.
It'll do that. E to the X.
That.
You have to go shift
Second.
ln. It's not e. It's shift ln.
It's the lowercase one.
Yep. And it looks like e to the x power, okay? This is a number. It's like pi. It is 2.7182818, blah, 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 and it goes on forever. This is an irrational number because it does not repeat and it does not end like pi does, right?
What? Wait.
Okay?
When we type that in, we just put second E in that.
Comager?
Yes, and that. Okay.
Hey, my
What?
little thing says I have 0 batteries.
I don't know. So
What?
it is a naturally arising number that plays a central role in the mathematical description of the physical universe, like pi. Its decimal expansion begins as shown. That's what it looks like, okay? This number is in compound interest, blah, blah, blah. Example 7. If the population in the United States grows or continues to grow as it has in years since 1980, okay? I don't know if you see down below where it says t equals 0 corresponds to 1980. Underline that or circle that so we know where year 0 stems from, okay? Then approximate the population in millions of the United States in year t, okay? Now, here's the deal. In year 0, what was the original population? In year 0, which is year 1980.
I don't know.
227E.
35.
227. No, wait.
227 is the principal number.
I don't know.
So this is my starting number. 227, but 227 is in millions. So they are telling me that 1980, there was 227 million people in the United States.
Yep, there
That's
were.
what they're telling me.
I
Ish.
remember that.
Yeah, you remember that in 1980? Okay. What's up? You need me?
Oh, I wasn't born yet, that's right. I was gonna ask you a quick question.
Sure.
Okay, third period, you have 3 kiddos, Josh, Allie, and Keaton for stats.
Mhm.
I need for them to come in to play with the junior high on one song.
Okay.
And Angel's the other one, but she's with Streff, so probably better off like at 10:15. Would it be okay if they came in at
Sure.
10:15
That's fine.
tomorrow?
Sure.
Okay, thank you.
Do you want me to remember to send them down?
We'll try to all talk about it.
We'll try to all, yeah, okay. All right, sounds good. Okay, that sounds good.
Thank you.
Yep. All right, so 1980, if we were to plug 0 in, we would get 227. Like 227 is the starting amount. So 227, but it is in millions. All right, estimate the population in 2015. We're not going to plug 2015 in.
Why? Oh.
Shank this lady.
2015 equals
25.
a T of 35. So we're going to plug 35 in. Practice plugging this into your calculator. 0.0093 times 35. Plug it in. You can just do it all at one shot if you want. Okay, practice typing that in so you know how to do it. Practice typing this in so you know how to do it. These are just the notes for 5-2.
I got 314.33.
314.33. Does
Oh,
that
that's
seem like an
almost
appropriate
pi.
number?
Yep.
Yeah,
That's
probably.
almost pi.
That's in million.
3.14159.
Okay.
2658.
So 314 million.
That was
Yeah,
so
we
funny.
did. We watched
Somebody
the
look up real quick. What's the population of the United States right now?
What is the population?
No, of the United
What's the
States.
population of the United States right now?
I got this.
7.9 billion.
No, United States. We're not the
Oh my bad.
278,200.
That's a little bit.
I heard
BS.
332 million.
That's a little bit BS though because they took census not this year.
Yeah, well, they just did it.
Baby's born.
So 332 million. So not too far off, right? Okay. All right. When will the population reach a 500 million? First of all, what's a 500 million in terms of millions? 500 million. So 500 million is 500 million. Okay, so we don't know. We will eventually, at the end of this chapter in January, get to the point where we know how to solve this without plugging and playing, because I don't like to play that game. I don't like to plug and play. What number do you want to start plugging and playing? 35 was 314. You want 40?
45.
No,
58.
Let's go 50. Let's try 50. Okay, so plug in 50. You can use the same formula, but plug 50 in. 50 right here.
No, we need a way bigger.
How about like 87?
What's 50? Just tell me.
85.
What's 50?
85. 61.
50 is 361. Okay, you tried 85.
85.
What is 85?
50
Look at
is
me.
40.
500.42.
No.
500.42?
Yep.
Okay, try 84 now.
No, 50's not that.
361 is 50.
495.78.
495.78.
What did I do?
Then what is 50, Kelsey?
What'd
I
you
got
get?
440.9.
For 50? Are you kidding me?
I got 361.
Wrong.
What did I
Okay,
do?
so it is somewhere between year 84 and 85. So we're still in year 84 though, right? Okay, so it would be the 84th year. What is year 84?
495.
What?
What am I doing wrong?
Partway
Oh, I know
through,
what I'm doing wrong.
1980 plus, what do we have, 84? Is 2064. Partway through 2064, so maybe like July of 2064 or whatever, right? It's partway, but we're
I'll be
still in
60
year
years
2064.
I'll be 60 years old.
Dang.
I'll be 59.
Okay, that's when we'll reach half a million. Half a billion. Okay, happy with that?
No, go over a little bit.
I don't want
Okay,
to
we'll go back to
We're just plugging and playing.
Oh, I have not 4-3.
Good?
Yes.
Yes? Okay, example 8, last one. These are logistic models. Okay, everybody listen to this real quick because we've never done these before. In all of algebra class, we talk about exponential functions, we talk about linear functions, quadratics, we talk about absolute value functions. We have never talked about something called a logistic model, and the reason why is it's because it's a very ugly function. Look at this thing. But realistically, logistic models are what they use for population, okay? I'm going to show you why. In an exponential function, if we're talking about in terms of population, an exponential model looks like this, okay? That's what exponential functions look like, right? But is it realistic that our population would continue to go up and 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 up forever and ever and ever?
People die.
People, well, even with people dying, the population's still
But
increasing.
they have a, what if somebody hits us with a bomb?
Well,
A big bomb.
assuming nothing weird is going to happen, assuming that we're already accommodating for the people that are dying, our population's still increasing. Why will it not increase forever and ever and ever?
Because
there's like
the
a
amount of people.
capacity.
Yeah, we are not going to be able to house all those people. We're not going to be able to feed all those people. It's the same way for like fish. If fish keep multiplying in a pond, at a certain point, we're going to have too many fish and we're not going to have enough water for them. Like all you're going to do is see fish in the water. You're not even going to see water, right? Like there is an equilibrium there. So watch this. We've never seen these before. Logistic models. This is what they look like. They start as an exponential function. They go up and then they level off. And there is a horizontal asymptote that lives here, which is the capacity cap. It's like the maximum amount that we can have in the pond to accommodate that many fish. Like that's the max amount of fish that we can hold, right? So logistic models, according to population, are better than exponential models because they take into consideration that cap, right? Okay, so this is something that we don't ever learn just because it's a really ugly function, but it has a horizontal asymptote because it's accommodating for that cap, okay? So the population of fish in a certain lake at a time t months, circle or underline or do something to the word months so we know what units we're talking about, is given by that function where t is greater than, why does they say t has to be greater than or equal to 0?
Because you can't have negative
T is
population.
time. No. T is time, right? T has to be greater than 0. There is an upper limit of the fish population due to an oxygen supply available, food, etc. Graph the function and find the upper limit on the fish population. So I want you to take in your graphing calculator and you're going to type this in exactly the way that they have it here. You're going to type it in as 20. Can you do alpha y equals enter on your?
Yes.
Yes, okay. Do alpha y equals enter. Make sure that you put it in as a negative t over 4. Okay? And you should end up with a function that looks like that-ish. It should level off at a certain point. Try to figure out where that certain level off point is. What is that upper limit? How many fish are we allowed to have?
Just plug that equation in.
Just plug that equation in for your
How do
y
you get a
equals.
T?
10, 15.
How do you get a T?
Oops.
Yeah.
What?
What's a T? How do you get the T?
Oh, just x. Yeah, just x.
What is the T right by the X?
What do you
It's a
think?
different variable.
You know, like then the calculator.
Is this how
That is like polar coordinates and stuff. Don't even worry about it.
I
What do
have
you do with
6733 points.
That's what I have.
Now
What?
I have
4708 points.
Wait, where did you
Wait,
go?
where are you plugging?
No,
What?
I'm on the graph.
Are you graphing
What are you
it?
doing?
Oh,
What
no.
are you doing?
Graph
What
it.
window should I put?
wait.
Graph it. I want the graph.
What window should you put?
I want the graph.
You too.
Negative 1,000 to 1,000.
Okay.
Okay, now what? What am I looking
Plug
at?
it into the graph.
I
I
still
do
do not see it.
Okay,
Yeah, I
you
don't
can't
see
see
it
it on the
either.
graph,
Yes, I can.
right? Can you see it on the graph?
Yeah.
No, it's two.
Your window needs to go like all the way up to like 50,000.
What?
I know.
My window's
So-
negative 10 to 10 and it's fine.
Can I go 0?
That's because you have something else graphed in there.
Steal some of Jason's.
Okay, X's go from 0 to 50. Y's
50.
go from 0 to 50,000 on your Y's.
Right.
Do that for your window.
Oh, I see it.
Help me.
You're right. It does level off for you.
Okay, do that for your window. When you type this in, do that for your window.
Boom!
Okay, does it do one of these things?
Yeah.
Where does it level off? What's this value right
I
here?
Oh,
couldn't
it's
tell ya.
Zoom in.
It's like.
Find where it levels off.
Like 200.
It's like.
Why does it do this?
Marcus, you mean 2,000?
Help me.
20?
Oh, yep. 20,000.
It levels off at
Like 20,000.
20,000. Do you know why?
Why not?
Because that's embedded into the formula. They're saying that's the maximum amount is 20,000. That's the cap. That's where it's at, right? So this lake will not hold any more than 20,000 fish because we don't have enough supplies. Like we don't have enough food in the lake to accommodate more than 20,000 fish. That is absolutely the maximum amount that we can hold
So why is the Earth keep going
Girl.
up? Why
What?
does the human population keep going up?
because we haven't hit that max yet. There is a max.
Maya!
We just don't know what it
We
is.
just don't know what it is.
I
Well,
literally-
that's yeah. There's a lot of people out there that are worried like that we're gonna run out of room. Like that's why they're like, can we start putting people on Mars? Okay, just don't have babies anymore. Just quit reproducing. Just like that's why China. Do you know China has
Yeah,
like
like,
a
look at this
rule that they can only have one child because they are running out of room in China. That's
Yeah, it's a
why.
one-child rule.
conversation.
But if they only have one child, like 2 people are having one child, so they're actually narrowing the population down. They're putting that rule on there, right? So they're narrowing the population down.
We talked about
And
this.
now I think they've lifted that because I think they're okay. So they'll let them have they'll let them have like 2 kids now
They
instead
said
of
that
just
you
one.
can have up to 20 million people on it.
Okay.
It's really bad, so I want
So we haven't run into that yet.
Why would you
So anyway, there's that. Okay?
People
Happy
will
with
have
that?
less of a chance to find their soulmate, and then they won't even reproduce at all, and then we'll be fine.
137.9.
No, because people will have one kid over here and one kid over here and one kid over here with different
Like my
people.
No,
Like my
why?
They'll have them all over.
No,
They'll
there's less
not.
people. There's
No.
less
Like my
males
mom.
to choose.
Anyway, all right. So you should have this.
for.
That you should have this 5-2. You should have this homework assignment. You should work on this homework assignment with the amount of time that remains in period.
I have some questions.
Okay, I will float around and answer questions. The first chunk of this is just asking for the transformations. Yeah? Like what is the 3 doing? What are all these numbers doing? Okay? There's that. Work on your homework assignment.
I need you first.
There you go.
I need your help.
plug it in here?